Let's finish this beast. This is it. All right, after today, we will actually be 20% of the way through Unit 3. Okay, throw it in the basket. All right. This is a continuation of what we did yesterday. We're going to add on to a little bit. Baby steps, right? So we're going to look at the sine and cosine function, but we're going to consider stuff that lies in wild quadrants. Sound good? All right. Ooh, what we're actually going to do is something called the component form of a vector. So this is your intro to vectors. We're going to do a lot more vectors after the AP test. I won't give any homework after the AP test. It's going to be, we're going to do stuff in class and see, like, you know what I mean? What we do, we do. What we don't, we don't. But what I want us to realize is this. If I'm given an angle, do you guys know a little bit about what a vector is? It's a direction and a length. Like, that's a direction and a length. It's a vector. Which vectors are not technically, I don't think they're on the AP test, but they can be with the unit circle. So what I mean by that is, over here, I have a theta, I have a point. Can I find, how have I been finding the radius of my triangles given a point? What do I do every time? Pythagorean theorem, right? And the Pythagorean theorem is a squared equals b squared plus a squared plus b squared equals c squared, right? So this formula right here, you're going to see sometimes. It's your radius of the circle equals square root of x squared plus y squared. It's just Pythagorean theorem. Square them, add them, square root them. Okay? Some other things that are going to pop up. My sine, have you guys noticed with that yet, is always my y, right? No matter the reference angle I've been making, sine is my y over r. It's my y coordinate over my radius. So it's whatever y is over my radius, because when I find the radius, that's my hypotenuse. Y is my, you know what I mean, I have my opposite. Right? And my opposite is how high I went. That's my y. I don't know why. I don't like that they wrote, that's your y-axis. Oi. Right? Oi. So cosine is x over r. Again, this is what we've already done. If you don't like the way this looks, that's fine. We've already done it. It's your adjacent over hypotenuse. But our hypotenuse is our radius. It's just a different way to conceptualize this. Actually, we've done the same thing now like 4 times in different ways. Okay? So get really good at one way. And tangent is opposite or adjacent, or we've talked about y over x, or sine over cosine, right? Now I'm going to blow your mind, so what does this actually mean in context of like going in reverse? Flip that? No. Can I solve for y with this equation? What would you do to both sides? Multiply by r. So could I say my radius times sine of theta will equal my y coordinate? So if I'm given a radius and an angle, could I come up with an xy coordinate for it? That's called component form of a vector. If a rocket's fired at 20 degrees at 10,000 miles per hour, can I turn it into an xy coordinate? Yeah, my x would be, or my y would be, 10,000 miles per hour times sine of 20 degrees will give me a y coordinate. Because if I have an xy coordinate, I can do math with it, right? I can manipulate it. To find x, I would do r times cosine of theta will equal x. So again, I have an airplane flying at 315 degrees, going 300 miles an hour. Can I turn it into an xy coordinate now? I can. I need an angle and a radius. If I have those two things, I can convert anything to a coordinate. What's tangent going to be of what's going on at here? That's going to be my slope, right? Tangent's my slope of my xy coordinate. This is, if you guys go on, like in college, if you take physics, you guys taking this class is going to be huge because this is going to be in physics. Like this is one of the first things you learn with motion. Sound good? Honestly, if you use this a lot, it's really straightforward. Like it makes you feel really smart when you go start taking engineering classes and it's like you have a weight and where it's moving and the force and you just do this and then boom. Then you just add things together. Like if two airplanes hit and one's going at a certain angle, one's going at a different angle, and you know how fast they're both going, you turn them both into XY coordinates and just add those two coordinates together, and that's where they end up. Or two cars when they crash, they hit and then they skid. They know exactly how fast each car is going because of this right here. Like we are getting to real life math. Like this is, you can do like things forensic scientists can do now, just with this. All right, I'm excited. All right, so let's try one. I'm gonna give you an angle. I'm gonna give you an angle and a radius. So we have an angle and a radius. I want to find what point would that be on the graph. That's not how I would do that. I'm going to do it my own way. Here's how you do it. They want me to find a reference angle, find the reference angle, and change it based on the quadrants. I'm going to use the unit circle. So how do I find my x coordinate? It's r cosine of theta, right? What's my r? 5 times cosine of 4 pi over 3. Well, what's cosine of 4 pi over 3? Negative a half. So this is 5 times negative a half. So it's negative 5 halves. So again, the formula looks scary, but that's not too bad, right? It's really nothing that we haven't seen. So my y would be r sine theta, because remember sine goes with y, cosine with x. So I do 5 times sine of 4 pi over 3. And according to my unit circle, that's negative root 3 over 2, right? Oh, I put that parentheses in wrong. My bad. So that's 5 root 3 over 2 negative. Any questions how I got those? Unit circle gave me the cosine or sine. So what's my final answer? What's my p that they wanted? I'd write it as one big point, right? What? Oh, me. I wasn't done writing it yet. That's how I write my 5s now. That's not good. This is going worldwide, guys. Oh, that's not much better. All right. Which quadrant would this be in? Third. If I didn't have the graph, I would know that because they're both negative, right? Okay. So that's engineering, guys. You guys are engineers now. Congrats. You can do this. We did a problem like this with football players. You can use their weight and their acceleration and the angle they're going, and when the football players hit, you'll know exactly where they'll end up by doing that, adding the 2 points together. Anyway, I digress. All right, let's do another one. Let's use reference angles. Bless you. A sneeze. A sneezance. It sneezed up on you? All right. So let's... All right, we've done this. We've done this one. Why are we doing it again? All right, we're in quadrant 2. I know cosine's negative 1/3. Why does it have to tell us quadrant 2, though, if cosine's negative 1/3? Doesn't cosine theta equal negative 1/3 here as well? Remember, they cycle, right? Cosine equals a half in 2 different spots. So they have to tell us the quadrant now because then we know it's that one, not that one. They won't always give you the graph. Do you know what I'm saying, though? Quadrants matter. Because these have the same x value. So thankfully, they told us this. And also, if I'm in quadrant 2, I know sine has to be positive, right? So even if I didn't graph it right, I would know when I do it, I need to get a positive sign. But because they gave us the graph, I know it's going to be negative 1/3. Isn't cosine a over h? So can I use, these are going to be the same value. So can I look at this and label this as 1 and 3? Oh, wait. 1 and 3. Now this comes into what my friend in the front said. Jiminy crickets. I can make that a negative 1 or keep it a positive 1, right? Yep. If I keep it a positive 1, I just have to remind myself that sine has to be positive no matter what. How do I find this missing side? Yeah. Super Bowl. 3 squared equals negative 1 squared plus, let's call it opposite squared. Let's not call it opposite squared. P for opposite. I got 8 equals P squared. So square root 8 equals P. Y'all agree? Could I leave that square root 8? Yeah. Can I also do it as 2 root 2? You guys remember how to do that? It's 4 and 2. Square root 4 is 2. I will warn you, on multiple choice, it'll be 2 root 2. You know what I mean? Like most of multiple choice I've seen, they do. All right. It's multiple choice. It's mostly multiple choice. All right. So that gives me this. Does that give me enough information to find sine? And sine's going to be positive. Do you guys agree on that? So I'm going to do 2 root 2 over 3. Anything else I have to do? Okay. No, you're right. You're right. Yeah, have confidence. The number one indicator of whether or not you're going to be successful in math class is how you feel going in day 1. If you feel like you're going to be able to do it or not. Like this take-home quiz that everyone's worried about. All right, this take-home quiz a few people are worried about. Oh, mamma mia. Find all values where cosine of theta is 0. So let's take a walk. Take a look at your unit circle. And no, don't touch it. I'm sorry, that was really mean. What I meant to say is please do not touch it. So where is cosine 0 on this? How many places is it going to hit it? 2. So cosine is it my x or my y? So here and here. So for what 2 values of theta was it 0? Pi over 2 and 3 pi over 2. For those of you who didn't know, it's because I have 0, 1 and 0, negative 1. So these were my 2 values where it was. All right, that was a quick one. Yeah. Where is cosine equal to 0? I'm looking at my unit circle. Where's my x value 0? Yeah. And you'll always have two answers, right? There's always two. You're going to have to memorize unit circle. Remember, memorize the first quadrant and then develop the rest off of it. It's not that bad. I've never had a student not get an A on the unit circle quiz. After one retake. Sometimes I allow one retake. Next week, probably. All right. Ooh, look at this. If tan is 4/3 and cosine is less than 1, which means it's negative, find sine and cosine. So I have to use some critical thinking here. Tangent is positive and cosine is negative. Now, if cosine is negative, it means I'm living on that side, right? Now, up here, tangent is negative because I have a negative and a positive. But down here, tangent is. So I know I'm living in quadrant 3, right? Do you guys see how I did that? I used the tan is positive here and here. Cosine is negative here and here. So where do they overlap? So that will let me draw my triangle out. I can draw a triangle off this, right? Tangent is opposite over adjacent, right? So that means it's going to be 4 and 3, right? Y'all agree on that? Yeah. But now since I'm in quadrant 3, if I want to make my life easier, well, what's going to be true about my sine and my cosine? They're both going to be negative, right? So no matter what I get, I got to ensure they're both negative. But to make my life easier, I went left and down, right? What's my radius going to be on this beast? 5. It's a 3, 4, 5 triangle. Do you guys see it? It's Pythagorean theorem if you didn't see it. But you should know the 3, 4, 5 triangle. All right. 3, 4, 5 triangle. Okay. Yes. If one side is 3 and one side is 4, your hypotenuse is always 5. It's the shortest. All right. Yep. You guys didn't know that? I taught you this in geometry. We did triangle families. Any multiple works. Any multiple works. So you could have a 30, 40, 50.
30, 60, 90.
No, those are angles. No, that's yeah, sure. Also, 5, 12, 13 is a really common one. A 5, 12, 13 triangle. 8, 15, 17 is a really common one. On standardized tests, they always use the triangle triples. If you're going to take the SAT, know them. All right. What's cosine going to be then? Cosine is what over what? Adjacent or hypotenuse, right? We at least have that memorized, right? SOHCAHTOA.
So I can figure it out.
What's sine of theta going to be? Opposite over hypotenuse. How come sometimes I do my fraction bar like that and sometimes I do that?
I do the same.
Look at us go. All right, let's do one more. A word problem. Ooh, calculator. Jinx. Yo me a soda. All right, let's do it. A machine shop wants to drill through a plate at point P. Calculate the actual measurement for a placement hole. Use your calculator to approximate it.
Why did they do like that?
What do you mean? They know it has to be 25 degrees off this, and they know it has to be 14 out. So they want to know what's my XY coordinate, plug in the CNC machine. With CNC machines will also do the angle and the length as well, but let's pretend like you're the guy who has to fix the CNC machine and make the most money. CNC machine? It's the one you program and it automatically like puts in stuff. All right. I have an, wait. Do I have an angle? Do I have a length? So how do I find x?
R's.
14 r times, axis r times cosine. So I'm going to do 14 times cosine 25,
Yes.
which is 12.68. Again, if I would have showed you this exact problem and like how do you figure out x and y back in like algebra 1, would you think it was legitimately 2 steps? Okay, one person would. Isn't that neato though? R times sine of theta is 14 times sine of 25. Hey, in your calculators, make sure you're paying attention to what mode you're in. The mode button. This one's in degrees. Some of our previous problems have been radians. Make sure your mode's in the correct one for the question being asked. So make sure it's in degrees. You'll get the wrong answer
One should have been.
when you're given radians. You need to switch back and forth.
I never did.
Well, no, because 25 radians could be 25 degrees. They're just numbered. You know what I mean? Like,
My bad.
remember, if there's a degree sign, you make sure it's in degrees. If there's not a degree sign, you gotta use radians.
My radio. Why can't I just be a radio? Yeah. Yeah.
Real life examples are very rarely in radians. There just won't be a degree sign. They could say the angle is 5. That'd be radians. But if the angle is 5 degrees, it's in degrees. No, it makes you feel silly. It's Rock 30. It's time to end the video. Thank you. Bye, everybody. Good luck on mock trial or whatever. Good luck in whatever you do in life.